Ha, yes. Welcome back. Right back with another video here. And this one, we're looking at ones that are rotated, not necessarily about the X or Y axis, but it could be any axis. Let's check it out. So, I took this from Paul's online notebook, calculus notebook, where we're determining the volume of a solid by rotating bounded by this y equals 2 times the square root of the quantity x minus 1 and y equals x minus 1 about the line x equals negative 1. So we're actually going to rotate it about this line here. So the thing is, this is going to relate very closely to the problems where we had multiple radii, right? The washer method. And it's also tricky because we're rotating it about the y-axis. But let's look at how this is going to play out, because now if we just think about those, each of those radii, whether it's the larger radii to the right or the smaller one to the left, they're just going to be one bigger. So we're going to need to make sure that we take each of these, right? So in this case, the one to the right is the y equals x minus 1. The one to the left is y equals 2 times the square root of x minus 1. So we'll have to solve for these for x in terms of y. So let's do that right quick. This one's easy, just add 1. So x equals y plus 1. This one might take me a few more steps. Divide by 2. I'm going to then switch sides. Square root of x minus 1, equals y over 2. Square both sides. X minus 1 equals y squared over 4. Plus 1 to both sides. That's just going to cancel there. So x equals y squared over 4 plus 1. So this would be my right equation. The one I'm going to then I'll subtract my left one from my right one. It's going to give me this function looking here where I'm rotating it about this axis, x equals negative 1. So now we're not just going to go right into it like we did with the washer method, because we need to think. This is going to be slightly different because we're going to need to think about the area of that as it's rotated around. But basically, if we look here, because this vertical line is just one to the left of the axis, it's basically just going to be these functions, but the radius is going to be one more than that. So what we could do is really just add 1 to each function. So this is just going to become x equals y plus 2, and this will just become x equals y squared over 4 plus 2. Because now we're finding the difference, right, as it's rotated all the way around that axis. And that difference is going to be impacted by the fact that the radius is bigger. And it's going to then impact like the size of each washer as we go through and think about the different cross sections. So now we basically have enough information here to get to integrating and using just the structure we've been comfortable with. So I'm going to then have just pi. I can look back and see that the interval on the y-axis is 0 to 4. And my right function is just going to be this y plus 2 squared. Then I'm going to have to subtract my left function, the y squared over 4 plus 2 squared. And this will be dy. Again, I'm letting my calculator do the heavy lifting here. So let me insert, let me take a photo here. And I think it's recording through all of this. Let me see. Oopsies. Let me take another photo. And what you can see here, hopefully in a minute, is that I just basically put in my integral exactly as it was, let the calculator do the math. So the volume of that region is about 60.318 if I did it with the pi there. But divide out the pi, I could then find it in terms of pi. So the answer should be 96 over 5 pi, which is indeed what Paul's online notebook told us the answer was for that example. So I thought that would be a good one to go over. Sometimes it'll be the case you have to think differently, where maybe you do, if the axis you're rotating it about is above both functions or to the right of both functions, you'll have to think critically about how to find the radius. So you may have to actually subtract the function from that horizontal or vertical line's value. But I think that's when sort of your critical analysis will come into play. Hopefully looking at the Khan Academy videos in addition will help flesh out the different types of examples you could tackle. Again, I know that I speak slowly. I've gotten that feedback before. I actually often get asked when I first meet people if I'm from the South. So I think watching these videos on double time it'll still be comprehensible and clear. So much love to everybody. Hope you're doing well. I'll put this right onto the YouTube channel. Talk to you soon.